Welcome back to End Time TV's On the Edge, Conversations in Emerging Medical Technologies. I'm Dr. Jonas Moses. With me today, Roger Stark and Dr. Sarah Sawtelle. We are talking about cognitive skills development and applied neurosciences. And just before the commercial break, I was getting ready to ask you this question, Sarah, which is, what is the science behind this?
Well, it's an emerging field, just like neuroscience is. Neuroscience actually has not been around very long at all. As everyone knows, back when I was a child, I was told my IQ is my IQ and it's never going to change. Fortunately, we all know that's not the case anymore. So what's fun about this is that the emerging science behind brainware is actually still being learned. We know a lot about how the brain learns, and we're learning more and more. There's been so many studies with Dr. Shaywitz and dyslexia, and looking at a longitudinal study of how their brains function when they don't read properly and as it's getting corrected. And that's becoming more and more common, is seeing more and more studies about things like that. Where we started was we took what was working in clinics at a very slow pace, and that there really was no controlled science behind it, but people knew it worked. And we've taken it and turned it into something that's a bit more engaging because it is a software program. So people actually get more caught up into it and get more focused. And there's lots of background back there about how the more motivated you are, the better you are learning, the better your brain is making those connections that it needs to make because you are totally engaged. And so we've been able to take the science that's been done, not necessarily with brainware, but has been done, and make a product that is using those same types of technologies by the sequencing, and we start everybody out at a level that they can do and they get engaged in it, and then the next level is a bit more challenging, and we'll stress those same functions in their brains in a new way so that it's a new development.
When we talk about learning, what areas of the brain are we engaging?
Well, we're engaging really the entire brain in our product, because what we're doing is we have focused on 6 major areas of attention, memory, visual processing, auditory processing, and some sensory integration. So really, the entire brain is active when they are playing brainware, when they're working with brainware. And each one of those, we have those 6 major areas, but we've narrowed it down to about 41 different cognitive skills. Things like discrimination, both visual discrimination and auditory discrimination, visual span, short-term memory, your long-term memory, your working memory, all those things that are really hard that you pick up from your environment, and you really need to be able to perform better.
Can you speak to what breaks down at all when someone is not a normal learner, kinds of things that are interfering with learning there?
Well, there's lots of conflicting studies out there. Most of the time, what they're finding, in particular, most of the studies have been done in children, of course. When they're struggling learning, it's usually with reading. It's caught usually around the 3rd grade. And most of those studies are showing...
Is this an age developmental sort of thing?
Well, it's actually because in school at about 3rd grade, the demands on what you're expected to be able to do change. And the way that they teach and what they're learning changes. And so that's when it's caught then. And really, it seems that most of it has to do with, 80% of it is visual processing. And it has to do with your memory and your attention skills. So a lot of times what's breaking down in a child who is disabled in reading is they're unable to actually compress the sentence as I'm saying it and make sense of it, hold that sentence, I say another sentence, or they read another sentence, hold that one, kind of combine the two, connect together, and then keep them together in their working memory while they're getting more information. They can't process all of that information at the same time, whether it's a visual, auditory, or whether it's really working memory functioning that is struggling.
I know that we talked before the program about autistic children. What's different there, and can they learn to read and be able to process this information?
I don't know how much you know about autism.
Not a lot.
And I thought I knew quite a bit until I started working with a group that have autism, and it's amazing the range of skills in the autism spectrum, and one child will have the same diagnosis as the one sitting next to them, and what they can and cannot do are totally different. So it's kind of a quagmire to walk into that one, because you can't say, well, it's these specific things that are wrong with the child. Usually when they're diagnosed with autism, it's mostly because they will have social problems, or they'll have a problem with communication. A lot of them are nonverbal. They can hear the information, but they can't express themselves right. They'll also have very severe relational problems where they won't be able to really relate with anyone in any kind of normal setting. Like sitting here, they wouldn't know how to respond to your question because they're missing whatever it is that helps us to be able to function in a normal conversation. They know a lot. They can talk about their special things. Some of them, like one child that we worked with, really loved horses, and she could tell you anything about horses and she'll repeat herself, but she can't have a conversation with you about the weather. So it's a hard spectrum to deal with, and some of them.
So they're absorbing information from. Are they absorbing information because they hear someone talk about it, or can they actually read?
Oh, they can read. Some of them.
Some of them can.
Some of them can read. Some of them can't. Some of them can talk. Some of them can't.
We call it the complexity. I like to refer to it as the complexity within the complexity theory. Okay. Because as Sarah called out, no two people are really alike. And in this study that Sarah was talking about, we had a child that just got excited about turning the product on and turning it off. That's all they did. Others had issues with the sounds on different activity. That's all they would do. But in many cases, we had a lot of success. And with brainware, you just don't know. Not that it's going to be the cure-all, but it certainly can have an impact within that population. And what we learned, because we did that with our standard protocols, what we learned that if we took and modified our standard protocols, we could have an even greater effect.
We're going to go to, thank you. We're going to go to a commercial break. Stay with us. You're watching In Time TV's On the Edge, Conversations in Emerging Medical Technologies.